Hello, my beautiful computer science students. Welcome back to another lesson in Unit 1, Using Objects and Methods. Today we're going to be moving on to Lesson 7, which is going to be all about strings and string manipulation and different things we can do with strings. We've introduced strings earlier in this unit, but so far we've just used them to really just to hold values for us and display values. We haven't really done much more with them. So that's where today's lesson comes in, where we're actually going to do more with them. If you're new here, hi, I'm Goldie, and I make AP CSA concepts easy, hopefully, to understand. Let's get into talking about what string data types are, because they're a little different than primitives. Primitive data types are the ones we've worked with most often so far in our expressions, like ints and doubles, and a couple of other ones we've talked about. But we also have class data types, also called reference data types, because they use what we call references to reference data in memory. Okay, so these class data types, that's where string comes in. Class data types, the easiest way to look at the difference between the two, class data types are going to be capitalized and primitive data types are not. Okay, easy way to remember it. We're going to make our own class data types coming up in Unit 3. We've actually already kind of made them a little bit, but we're going to go a little bit deeper with it in Unit 3, making our own class data types. We're going to talk about string, which is a data type that is already made for us. Where primitives hold one piece of data at a time, like int and double, both primitive data types, they only hold one single number at a time. When we declare that primitive data type, Java puts that little container in memory and stores the data there because it can only hold one piece of data at a time. So it just holds this one piece of data, a little leftover container there. Versus a class data type, Java allocates a space in memory, it makes a container, and it still uses a reference to that container, but inside that container, instead of holding data, that container holds a memory address. Okay? And that memory address points to the location of the data. And we've seen this like when we made our dog object, right? We had Mila as our reference. She had a memory address that pointed to her data, which was her name, her age, whether she was a good dog or not. So we've worked with class data types before because class data types can have a lot of data associated with them, like our dogs did. It's the same thing with strings. Strings are going to have a memory address that points to the location of a string. Now, strings themselves, they are class data types, but they're only going to point to one piece of data. And that piece of data that's being stored is going to be what the string is. Okay? So here's kind of a good visual for it. So primitive data type, here we are initializing int x equals 5. And in memory, we have x, the container, containing 5. Okay, and that's what it is. Okay. Versus class data types. Here are the two ways that we can initialize a string. The first one is what we've been doing. String example equals hello. Okay? And that's how we've been creating strings so far. The second type, now that we've kind of had a little bit of an introduction into what objects are, the second line is another way we can create a string, although it is less common. It is another way to create a string because a string is technically an object. Okay, string, less common, equals new string, and we call on the string constructor to construct hello, okay, as our new string. Okay, so both of those are ways that we can create a string. Now, in memory, what happens is example, it gets a memory address that points to the location of hello. All right. Now, that looks a little different when we do assignments. So let's say I have int x equals 5 and int y equals x. Okay. What happens in memory when I do those two statements together? Well, in memory, x gets the value of 5. I make a container and that stores the 5. For the second line, I make a container of y and I copy the value of x into y. So in the container of y, I get the value of 5. Okay? It makes a copy and puts it in that container. And that's how primitives work because they hold the data type. A copy is made, and in that container, I get a copy of that data. okay? Now, class data types, here's where it gets a little strange. So class data types work differently than what I just showed you with primitives and how assignments are made. Class data types work differently. However, strings are going to work slightly differently than other class data types when it comes to assignment. And that has to do with something called the string pool, which I'll reference a couple times in these notes. Let me show you how strings work in assignment, and I'm going to explain how it's different than primitives, but it's also kind of different than other class data types. So let's say I have string A equals hello, and then I have string B equals A, okay? That makes sense. So in your head, okay, A gets the value of hello and B also gets the value of hello, right? That's what happens. But what actually occurs in memory here? This is what happens. A gets a memory address that points to hello. That's the first line. The second line, B gets a memory address and it's going to point to its data. Now, what data is it going to point to? Here's where strings are a little bit different. Strings say, okay, if you want B to equal the value of A, take whatever A is pointing to and you want to also point to it in your B memory address. But notice how they're two separate hellos, okay? A is a hello and B is a hello. Even though they're the same value, the addresses are pointing to different locations, right? And that's what happens when you copy strings in an assignment, okay? They work similar to primitives, but different because they hold memory addresses. But they also work different than other class data types. And this is something that we're going to see in Unit 3. We're going to address this a little bit more. If we have other data types, let's say, well, we've seen dog, right? We've seen dog Mila equals, let's say I make a new Mila, right? I use the new operator, I make a new Mila. And then I make another dog, Fido, and I say Fido equals Mila, right? When I work with references this way, the difference is, and I'm sorry, I'm kind of cramming this all onto the screen here, is Mila, right, gets her own box, and it's going to point to Mila's data. Okay, here's Mila's data that I make her with. And then when I go to make Fido, Fido gets his own box. It's a dog box. But Fido is going to point to the same location in memory that Mila is. That's what this does. And that is specific to class data types. However, that's not specific to strings, okay? This is where string is kind of like that weird in-between. String wants to be a primitive, but it's actually a class, which is why we have statements like this, okay? We don't use the new operator here. Even though string is an object, we don't use the new operator. And that's because string, we can treat it like a primitive for all intensive purposes, right? We can treat it very much like a primitive data, but it's actually a class data type. Okay, so it's kind of a weird in between. This right here, what I wrote down here, we cover this more in Unit 3. Okay, so you can keep it in the back of your mind. You're not going to be tested on it right now. We're going to cover it more in Unit 3. Okay, so hang on. With strings, this is how we create a string. This is another way to create a string because string is technically an object, although it's less common, and you can basically treat strings like a primitive. Okay. So again, for strings, knowing what's going on in memory doesn't make much difference to us, okay, because they work a little bit differently than other class data types. Strings are also what we call immutable, which means once a string is set up in memory, we don't actually change it. All we do is if we make any changes to the variable, to the reference, we actually end up just pointing to a different location in memory. Okay, strings are immutable in that way, and that's really Java's built-in way to make strings like more secure. Not that we have to worry about security in this class particularly, but they're immutable to make them secure, essentially. Other mutable class data types like our dog allows us to change what's actually stored in that memory location. Like I just showed you with Mila and Fido. Those mutable class data types, we can change where their memory address actually points. So that if they point to the same object like they were doing in my example, changes to that object will be reflected in both variables, which is something we got to look out for and something we will definitely learn more about and practice with in Unit 3. Okay. So here's what I have just as an example of how even though strings are immutable, you can still treat them like primitive data types because they still work like you would expect them to, like we've been using them, right? So if I have string alpha equals Harry Potter, and I say string beta equals alpha, and then I have alpha equals alpha plus and the goblet of fire, and then I'm going to print off both of those variables and let's see what happens, okay? So if I have alpha equals Harry Potter, and I have beta equals alpha. So this is what happens in memory with these two lines right here, okay? These two lines, alpha equals Harry Potter, and when I do beta equals alpha, that's taking a copy of what alpha is and putting it into beta. So now, when I do this line and I change alpha, I take what alpha was, which was Harry Potter, and I add on, I concatenate it with, and the goblet of fire. So I have Harry Potter and the goblet of fire. So what the old address pointed to Harry Potter, right? But what actually happens is alpha says, when I reassign it here, I reassign alpha, it gets rid of this address and it is going to point to a new address, okay? So Harry Potter never really got changed here. It never changed. It, just got thrown out, okay? And it's now pointing to a new address, okay? And again, that kind of seems like it's splitting hairs, but it does matter, and it is important to know, okay? So now when I go to print off alpha and I print off beta, alpha says Harry Potter and the goblet of fire, whereas beta still says Harry Potter. Even though I changed alpha, that had no effect on beta at all. Even though right here, I said beta equals alpha. Remember, that's just one moment in my sequence. It's not a relationship. It is a relationship if you do other class variables, and that's going to come up in Unit 3. I keep saying wait till Unit 3, but stick with me till Unit 3, okay? But I have to make sure you know the difference here because it does matter with other classes. It does not matter with this, okay? Okay, here we go. Variables of class data types are allowed to be empty, so string is no exception. String is allowed to be contain no data, right? And in that case, when it contains no data, it's going to be null, okay? So string example, if you just declare it, it's just an empty box. There's no data in it. And it's not, well, there's never any data in a string box, but it's not pointing to any memory address. Same thing if you set it equal to null. It's just an empty box. It's not pointing to anything. Okay, so what ends up happening, that exception, that null pointer exception, happens when you try to do something to an empty box. Okay, you try to print off example, but example is an empty box. You'll get a null pointer exception. Okay. So we talked about concatenation before. I want to show you another way we concatenate here with our compound operators. So that string addition that we saw with Harry Potter plus Goblet of Fire, that was the plus sign, that was concatenation. That glues two strings together. We can also use that compound operator plus equals to add on a string we have already created. Okay? And remember, this creates a new string reference and it creates a new memory address because strings themselves are not edited. Okay? So that plus equals, what I used to use it for before was with just with doubles and ints. Okay, with those doubles and ints, right? So if I had x equals 5, and then I did x plus equals 3, right? X would now have the value of 8. Okay, so I did it with integers, and I could do it with doubles too, but you can also do it with strings, and when you do it between strings, it's just concatenation. So here for this code segment, I'm going to have hello world pushed together as my word that prints off H, okay? Because I have H is hello, H plus equals world, and then print off H, okay? Concatenation. One other thing we've also talked about before is how the print line statement works when handling strings, okay? So it's just worth repeating here. When that system.out.println is working, once it starts working with strings, like the first thing it encounters is a string, it treats everything else that it encounters like a string, okay? Because the print line, unless there's parentheses, The print line evaluates from left to right, like you're reading. So it says, hey, okay, I'm working with strings. I'm just going to keep working with strings. So what gets printed to the console is the sum is, and then the X gets printed, and then the Y gets printed. So the sum is 53 is what you actually see on the screen. Okay. But like I said, parentheses override that. So if I have this as my string, plus, and then I have this in parentheses, the parentheses gets evaluated first. So X plus Y is 8. And then the print statement will say the sum is 8. Okay. So hopefully you remember us talking about that. It's worth repeating here. That's specific to the print line method. Okay. And I guess I should generalize any string, right? So if I say string Z equals, and then I put this here, okay, even if it's not inside the method, the same thing applies. Java is going to do the parentheses first, and it's going to do integer addition. 5 plus 3 is 8. And so what gets stored in Z? The sum is 8. Okay. Same idea here. If I don't have parentheses, it'll say the sum is 53. Okay. I guess I should apply that to everything, but you'll see it a lot in print line statements. Okay. Moving on to something that is new is escape sequences. So escape sequences allow us to print off symbols or commands inside of a string literal. And you can include this in your print line statements. You could also include this in just a regular string. Okay, escape sequences can go in either. All escape sequences start with a backslash, and the next symbol tells Java what special case to print off. There's a whole list of escape sequences. Here are the ones that you need to know for the AP exam, okay? But there's a whole list of them if you want to look it up, okay? If we want to include a literal quote, we do backslash and then the quotation mark, single quotes. A new line is the N symbol. A tab over is the T. A single quote is just the single quote, and a literal backslash is 2 backslashes. Okay. So there's different escape sequences. Here are the ones you should know. You can play around with them in your IDE if you want to see exactly what happens. But let's have this. I'm trying to print this off. What it'll do is it'll see this symbol and it'll do a new line. So hello, new line, and then world will get printed. What about something here? Okay. Something here, you still need the quotes on the outside to encase your string literal. But we know that those outside quotes don't actually get printed to the console. So if I wanted them to actually get printed, I would use my escape sequences here. Okay. And then I have a tab in the middle. So what will get printed is my quote, hello, with a tab, and then world with a quote. Now, tabs are nice because tabs allow for lining up of items versus spacing. If you've noticed, spacing is very unreliable when it comes to printing to the console. The spaces don't always print like you think the spaces should. Like if you put 3 here and then 3 here, but this word, 3 here, but this word is longer, it doesn't align nicely when you just use spaces. But tabs align nicely. So if you're ever trying to print off a table per se, or a certain pattern of things you're working with, tabs are very helpful. Okay. Escape sequences, they're fun. Okay, let's get back into working with strings and string literals. So string literals, we've said before, letters, digits, characters, anything on your keyboard in terms of a symbol is what a string literal can be made up with. Now, when you make that string literal, each string literal is actually assigned an index. And indices in Java for the string literal, it starts at 0 and it goes up by 1 for indexing. Okay, so indexes start at 0 and then go up by 1 from there. And here's a special note, escape sequences, even though you technically see 2 symbols, you see the backslash and then like the symbol, escape sequences do count as a single index in string indexing. So keep that in mind. Otherwise, every single digit, space, whatever it might be, is made up of one index. So here is an example. String message equals APCS is a fun class. It obviously is, right? Yeah. So here's actually what's going on with Java's indexing. So A is the first character, and that starts off with an index of 0. And then from there, each character, including spaces, gets an index. Okay? So P gets a 1, the space gets a 2, C gets a 3. Everything, no matter the character, exclamation points, whatever they may be, gets a index. Okay? Go up by 1. So here's what this looks like. Now, why is that useful for us? Well, we're going to start using string methods. And to use string methods, you have to have indices in your string to refer to different characters that make up your string. Now, before we talk about those methods, let's take a brief pause and talk about libraries and the API. Okay? Libraries, when we talk about libraries, it's a collection of pre-written classes that you can use in your program. So there's things that have already been programmed that instead of just reinventing the wheel per se, you can use a library. Okay? You've already had the code. Let's use code someone else has written. An API, also called Application Programming Interface, that's a specific guide that tells us how to use classes in the library. Okay, so the API, when we talk about API documentation, it explains the attributes and behaviors of a class that we are going to use to help us understand how to use it. Okay. Classes that are in libraries are grouped into what are called packages. So for example, if I want to use the string methods that I'm about to use, or the math methods, which I will use in the next lesson, I have to import a package. Now, thankfully, these two packages are going to be automatically imported. Okay, they're part of the java.lang package, okay, the lang package, and that's automatically imported. Now, another package we've seen before is the java.util. Okay. Where did we use java.util? We used it with our scanner object, right? Because the scanner allowed us to get user input. Okay. And I said, just use it. It's code that has already been written. We are just using it in our program. But we had to import java.util. It's the same idea with the java.lang, but java.lang automatically gets imported, so you don't have to have an import statement. But that's the reason the methods I'm about to teach you from the string class, that's the reason we can just use them. That's also the reason we can just create a string object without having to write an object creating class. We can just use the string object because that class has already been written for us. Beautiful, isn't it? If you're interested in more, let me switch back here. Oracle. Okay. Oracle is probably the biggest name in terms of API documentation. So if you are interested in any class that you can import and what those packages are and how you can use them, go to, I think it's oracle.com, but if you just Google Oracle, that's going to have all of the documentation in one pretty little website. Okay. So let's jump back over to string methods. There's so many string methods, but there's luckily only 5 that you have to know for the AP CSA exam. And these are arguably the 5 most common that you would use when encountering strings anyway. So you're going to know these 5. Okay. They're part of that java.lang package. So because it's automatically imported, you don't need an import statement. You can just use these in your program, right? You don't have to write a class for it. You don't have to do any of that. It's already been written. We can just use them, okay? Which, remember, is a form of abstraction, okay? Procedural abstraction. When you can just use a method like this and know what it does without having to see the code that's already been written, that's procedural abstraction. Oh, beautiful. It's a beautiful thing. Okay. So each of these methods I'm about to show you, they, when you call them, they return information about the string you're calling them with. Okay. So we're going to go back to AP CS is a fun class, okay? Because it's such a true statement. We got to use it, okay? So here it is laid out for you in a table with the indices, just to make it easy as we're learning what these methods are. Okay, the first method is dot length. Okay, so this method, the way this table is organized, the method returns an integer. Here is the method. Now the method, it uses the dot notation. The method name is length, and then there's no parameters inside here. Okay, and what does this do? It gives you the length of the string. Okay, how does it know which string that it needs to give you the length of? That is where the reference comes in. So message is our reference to AP CS as a fun class. So we use the reference, most of the time we use the reference. We use the reference in order to say, hey, this reference, what is the string that it's pointing to? I want to know what the length of that is. Now, when we talk about the length of the string, what does it mean for the length of the string? It means how many total characters are there in the string, okay? So you would count them up. 1, 2, the space counts as a character, right? So 1, 2, sorry, I keep clicking off my PowerPoint. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I keep clicking off my PowerPoint. I'm sorry. 16. I've lost count. Counting. I've lost count. But I count up all those characters. Ta-da! And then, who knew I was so bad at counting here? But I count up all those characters. How many total characters there are? There's 21 total characters. Okay? What you can also do, your indices go from 0 to 20. And because the indices are inclusive of the endpoints, that means that the total characters is always going to be one above your last index, okay? Is another way to think of it. But since there's 21 total characters in the string, this method is going to return an integer value of 21 in this example. Okay, here's another one, substring. Okay, now there's two, substring is actually an overloaded method. Oh my gosh, we just talked about that, Goldie. We just talked about overloaded methods. I'm going to say we did, and it was so great. So substring itself, when I say there's 5 methods we're going to learn about the 2 substring methods because it's an overloaded method. There's 2 ways we can use substring, okay? Here's the first way, okay? Where we have dot substring, and it accepts 2 parameters. Okay? I call it int from and int to. Int from and int to. So 2 parameters, and it's going to return a string. Okay? What type of string is it going to return? It's going to return the substring beginning at whatever index you give it first, and ending at 1 less than 2. Okay? So that's TO2 minus 1. TO referring to this 2 over here. Okay? So if I have message.substring 6, 17. Okay? So I give it 2 integers, 6 and 17. Here's what it's going to do. It's going to start at 6, at index 6, and go all the way up to, but not including, index 17. Okay. Not including index 17, 1 less than 2 means that this is a fun cl. That is what's going to get returned. Is a fun cl. Because it goes up to, but not including that 17. Okay. So it's substring. So substring, you have a string. Substring gets a portion of your string. Substring. Portion of your string. Here's the other substring method. Okay? It's also called substring. It's overloaded. Right? This only accepts 1 parameter. 1 parameter. So remember, that's how Java tells the difference between the 2. 2 parameters, 1 parameter. Okay? I love when stuff connects. Sorry, I'm so giddy about this. So substring returns a string. Okay? And you just pass it 1 index. And it returns the substring from, so meaning you start at whatever index it gave you, to length. Okay? Meaning all the way up to the length minus 1, right? So if I say message.substring 15, okay, 15 starts here, up to length. Length is an index of 21 because length is 21 characters. But remember, we go up to, but not including 21. So even though I don't have 21 as my index, that's okay because I don't actually need a 21 index. I go up to 20. Okay. So what gets returned is class with an exclamation mark. Okay. So substring, when you just pass it one index, it starts at that index and just gives you the rest of the string, is the best way to think of that. Okay. 3 methods down, 2 to go. This next one is index of. Okay. So index of is going to just accept a string of some kind, and it's going to return an int. It returns the index as an integer of the first occurrence of str. Okay, whatever string you pass it, it returns the first occurrence of it. It returns -1 if it can't find that string. Okay, why does it return -1? Well, because -1 is not a valid index. You can't have negative indices. So -1 is kind of an alert to like, hey, you actually couldn't find this string, so let me return -1, which is not a valid index. So you would know that it wasn't valid. Okay, so here's 2 examples. I have 2 examples for this one. Message.index of A. Okay, so this method starts here. Oh, I see an A, but it's an uppercase A. Okay, remember, we're case sensitive, and I'm asking for a lowercase a. So it's going to go through where is the first occurrence of A. Okay, I see an A over here as well, but it always returns the first occurrence, which happens at index 9, which is what gets returned. Okay, message.index of capital I. Where is capital I? There's a lowercase, but I need a capital. Oh, can't be found. I went through the whole string, wasn't found, so that method is going to return a -1 because we weren't able to find it. Okay. The last one, compare to. Okay, I love this one, but it is a tricky one. So compare to, it's going to return either a positive or negative number or 0, depending on the relationship between the numbers. Okay, so this dot compare to, you're going to pass it a string that we call other. Okay, the reference that is going to be called is sometimes referred to as this and other. Okay, this method returns an int. Okay, what int does it do? Okay, well, it's going to compare 2 strings. It's going to compare this and compare other. And between this and other, if it's going to return a negative number less than 0, if this is lexicographically less than other. Okay, what the heck does lexicographically mean, Goldie? Okay, give me a second. Equal if they're lexicographically equal. Positive if if this is lexicographically greater than other. Okay, which doesn't make any sense if you don't know what lexicographically means. Okay, it's basically dictionary order. Okay, it's a little bit beyond dictionary order though, because a dictionary, while dictionaries are not case sensitive, right? They don't uppercases and lowercases don't matter in a dictionary. They do matter in lexicographically ordered values. Okay, so because of that, you can't compare a lowercase a and an uppercase a. It's going to read those as different letters, and based on lexicographically where they're located, it's going to return either a positive or negative number, not equal to like you would expect, not a 0. So what happens? What does that mean for you? Okay, on the AP exam, you are only going to be comparing same case letters, or some cases same case words, but same cases. You don't have to worry about mixed cases on the exam, so I'm not going to cover that right now because I don't want you to worry about it. You're only going to be comparing same cases. And let's just get the basics of this method down. So when you think of dictionary order, think of this. If I assign A as 1, B as 2, C as 3, etc., okay? Think of it like that. So if I have a string called first and it's just equal to C, the letter C, and I want to compare first to the letter A. So it's saying I want to compare this to other. Okay. I want to compare C to A. Okay. Now, when I show you this, I don't want you to worry yourself about the number. Okay. That's what it's going to return. Okay. I'll explain what the number means. But again, on the AP exam, not only does it not matter about cases, you'll never have to worry about comparing cases. You also won't have to worry about the number. I just want you to focus on if it's positive, negative, or zero. Okay, so let's compare A to C, okay, or C to A. Okay, C was my this, and A was my other because it got passed as the parameter. So this is lexicographically greater than A. This, what I'm using, is lexicographically greater than A. Do I see that? How it's greater? Okay. Because it's greater, I'm going to return a positive number. That's what I need you as the student in this class to think about. This is greater than this. Okay, right? C is greater than A. C is greater than A. So I'm going to return a positive number. Okay. Now the number I actually return is a 2 because it's 2 greater. Okay. But I don't want you to worry about what the number is. I want you to worry about if it's positive, negative, or equal to 0. Okay. So this C is greater than A, so it's going to be a positive number. You just got to commit this to memory. It's tough, but you got to do it. Okay. Now, the reason why so many students struggle with this is they think of this as C as coming after A in the dictionary. And they're like, okay, C comes after A, so it's less than it, so it's a negative number. Don't eliminate that thinking right now. You want to think in your noggin here. C is greater than A. C is greater than A. Don't think about where it comes in the location of the dictionary. C is greater than A, so it's going to return a positive. The next one, C compared to G. C, this is going to come before G. C is less than G. Okay? C is less than G. G is larger. Because C is less than G, less than your other, it's going to return a negative number. Okay? In this case, 4 because it's 4 less. Okay? It's negative. Or if they're equal. If C compared to C, if they're exactly equal, you're going to have a 0. Okay? Now, this is comparing letters. We can also compare words, but we're going to do that more in the homework and a little bit later on when we get into more in-depth strings, okay? For now, we're just going to focus on the letters. Those are the basics there. Okay, I got some examples here. Okay? I know we're rocking on this long video right now, but this is going to be good. Some examples. If you want to pause and try them on your own, that is totally fine. I'm going to go over the examples pretty quick here. So substring 0 to 2. Okay, there we go, 0 to 2. But remember that 2 is not included. So AP is what that code is going to return. 11 to 14. Okay, there it is, but 14 is not included. So fun is going to be returned by that substring. Okay, 15 to 21. Okay. 21 is not an index. However, remember, substring does not actually include 21. Okay? You would get an error if you tried to use a index that was not in here. Like if you went 15 to 50, that would have an error. That error is called index out of bounds, okay? Because you're trying to use an index that doesn't exist. So 21, it doesn't exist. However, remember, substring method, it goes one less. 1 less than 21 is 20, and 20 is a valid index. So this substring is going to return class with an exclamation mark. Okay. 0 to 1 is going to return A. Okay. So when you have two indexes right next to each other, that's how you extract a single letter from your string. 6 to 7, 7's not included, you're going to return an I. Substring. Lots of practice. Next practice. Okay. Let's check out some of these. These are a little bit, what's going on here. Substring 0 to 0, that actually returns an empty string. Okay, if your indexes are the exact same, you're going to have an empty string. 20 to 21. Okay, again, 21 is not a valid index, but the substring takes one less than that when it comes in the second spot. So that's going to return an exclamation mark. That's how you get the last letter or the last character. -1 to 2. Where is -1? You get a compiler error. Okay, index out of bounds. Okay, index out of bounds. Now, you'll get a compiler error when you go to compile it and you have a negative index in your substring. Pretty sure. Sometimes that index out of bounds, though, it happens when you run your program. Sometimes it's a runtime error because you don't hard code numbers into substring. Okay? We'll see that more when we work with our string algorithms in the next unit, unit 2. Okay? But for now, index out of bounds is where you try to access an index that doesn't exist. Remember, when we have just a single index, we pass it. We start at that index and pass it the rest of the characters. So if I start at 0 and pass it the rest of the characters, I basically just pass the whole word back. Okay, words.substring gives the whole word back. Substring 0. Words.substring 11 starts at 11 and gives the rest of the word. So fun class with an exclamation mark. Okay. All right. Here's some other fun things. So you can have some methods nested in with your substring. Okay, so like here, I have words.length nested in to my substring. Okay, when you have nested method calls like this, Java will work with the inside method call first. Okay, so words.length is 21. We said this message has 21 characters. So it'll say, okay, what's the substring from 6 to 21? Okay, from 6 to 21, or one less than 21, is a fun class, will get returned. Okay. Here, words.length, it can be an expression because .length returns an integer. And so words.length is 21, and then I subtract 1, which is 20. So 3 to 20, again, not including 20, CS is a fun class. Okay. So that's a method inside of another method. Here I have a method chain. I have words.substring.length. Okay. When I have a method chain like this, the method chain starts on the left. Okay, so words.substring 3 to 14 gets evaluated first. What is that? Okay, CS is a fun. Okay, CS is a fun. That is my string. And now I do .length of that. Okay, so .length means this string right here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There, I counted right that time. Look at me. Okay, there's 11 characters, so that's going to return 11. Okay. 11. Okay, here's an example of both nesting and chaining. What a fun thing. So look at it. I have words.index of A. Okay, so that's inside. So I'm going to evaluate inside first before the chain. Okay, inside first. Words.index of A. Where is A? The first occurrence of A is at index 9. Okay. Next, I have a chain. Okay. So next, I'm going to do words.substring 9. Okay, because I evaluated this whole piece right here. I just evaluated it was 9. So this now is words.substring 9. Words.substring 9 starts at 9, goes all the way to the end. A fun class is what that whole highlighted piece gets evaluated to. And now I have to do .substring 6. So that means I have to find my index of 6, 0, 1, 2, 3, 4, 5, 6. C starts 6, and I do the rest of the word class. So that whole nested method chain returns class with an exclamation mark. Fun stuff. Okay, this is the last little bit here. It's a long video, so thank you for sticking with me. Let's finish off with class methods versus reference methods. So the methods we use today, we use with strings, are called reference methods, meaning we needed a reference variable in order to use them. So if I have string digits equals, and then I just have digits in a string, if I wanted to get a substring, I have to use the reference of digits. If I wanted the substring of this, I have to use digits as my reference before my method call here. Okay, use a reference. So that's what's called a reference method. Okay, digits being our reference variable. We also have what's called class methods, meaning we use the class name to call the method we use. And we're going to see that in our next lesson, lesson 8, on the math class. So if I want to call a method like square root, okay, I use math as my, since math is my class, I use math before my method dot notation in order to use that method. Okay, I don't actually use a reference. Okay, so the differences between these two are because reference methods refer to an object and class methods do not. Class methods are what we call static methods. And that keyword static, you've seen it before, but you don't quite know what it means. The keyword static, we're going to discuss it more in Unit 3. Okay, we're going to discuss it more in Unit 3. But class methods contain static methods, meaning that they don't act on an object. So we don't use a reference for them. Versus reference methods use a reference because they refer to an object. Okay, so the difference between these two, class methods belong to the class itself. They're static. You call them using the class name, like we're going to do in our next lesson, lesson 8, about the math class. Okay, what we just did was use reference methods. Reference belong to an object of a class and to that specific object, and we call them using the reference to that object, like string. Okay, we had to call it using that string object along with the method. Okay. All right, that wraps up our lesson today on string manipulation. Thank you again for sticking with me. If you like this video, please hit the like button and subscribe to my YouTube channel for more CSA content. Our next lesson is lesson 8 on the math class, and it's going to be our last lesson in Unit 1. So I'm so excited. Go there if you're ready, and I will see you in the next video.